Assalamualaikum warahmatullahi wabarakatuh and good night. Today I want to present about my project report that I have done, and the title is three-phase Y connected generator, transmission loss and load. First, let me introduce myself. My name is Ahmad Hafizul Rahman bin Azraei, and I am from RK23, and my metric number is 1810911196. Okay, before we go through this presentation, first let me show you the report that I have done. So this is report that I have done. You can see it. The analysis of three-phase Y connected generator. You can see they are my name, Ahmad Rahman bin Azraei, and my metric number 1810911196, and I am from RK23. In this report, there are things that we really needed, which is introduction, objective. You can see the objective, the methodology, the result, and the last one is the conclusion. Oops, I forgot. Before the conclusion, we got the discussion, and then we got the conclusion. Okay, so when I have done this report, so I get the task to do this video presentation. So let's continue this video presentation. Okay, so introduction in this presentation. Okay, for the introduction, we should know that there are in three-phase system there are two connected, which is Y connected and delta connected. Then in the Y connected generator, we should know there are two types, and then which is voltage and current. And for voltage, we should know that E line equal to Z3 E phase, and I line for the current, I line equal to I phase. I repeat, for the voltage, we should know that E line equal to Z3 E phase, and for the current, we should know that I line equal to I phase. Then we should know what the voltage drop. Electricity Supply Application Handbook V3 ESAH_V3 say the limit for the voltage drop for 275 kilovolt voltage level is plus minus 5%. So when you calculate the voltage drop, you can get the 5% plus minus 5%. You can see that after this I will show you. And then the formula for voltage drop is V drop equal to V supply minus V load over V supply times 100%. And then you can get the percentage, and then you can get the value of the percentage of V drop. Next, we should know the power factor. The power factor for 132 kilovolt is 0.9. The power consumed by the load can be calculated using two methods, which is 2 wattmeter method and conventional measuring method. In the slide, you can see there are one formula, and this formula is follow up is for conventional measuring method. You can see it. P load equal to 3 times VPL times 1 PL times cos theta. So with this formula, you can calculate the conventional measuring method. Okay, next we continue to the objective of this project report. So there are three main objectives that we should do in this report, and the three main objective is: first, we need to evaluate the parameter for three-phase system. Second, we need to analyze the differences of value from the calculated value and stimulation value. And the last one, we should justify the normal operating condition for the system. Next, let's go to the methodology. Okay, in this methodology, first of all, we are get the value from V line is assigned for student, and value for transmission and load impedance is assigned for student. And then, with the value that are given, we should calculate the parameter of three-phase system. and then we can get is we drop and the power consumed and I line, I phase, and also V phase. Next, after we already done calculate all of parameter of three-phase system, we should using PSIM software to do the simulation. So after we do that, then we can compare the calculated value with the simulation value, which is we can see there are differences or they will be the same. Okay, next I will continue with the result. So the result you can see here, the V line, two line that are given is 275 kilovolt, and this transmission line, which is that I have get from my metric number that I have given, and here you can see it for the transmission loss, I get 96 plus imaginary 11 ohm, where L equal to 0.035 Henry. Next, the transmission load equal to 81 plus imaginary 9 ohm, where L equal to 0.0285 Henry. So you can see the formula that I have tell you for the first time, that is E line equal to set 3 E phase. And then you can see the E phase value when we take the 275K over set 3, we can get the total for E phase, which is 158.77 kilovolt. Here the result, you can see this result I get from the PSIM software, and you can see the graph, and then the below there the value that I already calculate, and I use the value to compare with this result that I get from the PSIM. Next, also for I line equal to I phase, here the figure show is for the I phase, and then you can see next here the calculated that I calculate for I phase, and then I compare to the result and it's same. Okay, then let's proceed to the next figure, which is E phase load. Here is the result that I get from the PSIM. Then in the below that, you can see the calculation that I have made on my own, and then I use this to compare. Then we calculate the voltage drop, and we got the percentage is 54.25%. Okay, and then after that, I already tell you there are two types. We want to calculate the meter, which is watt meter method, and then conventional method. Okay, for the conventional method, you can see this is the graph that I get from the PSIM software, and then below that you can see the calculation that I have made on my own, and then this is for the watt meter method, and then the second method is conventional method. So you can see the formula that I have tell you before, P load equal to 3 times V field load time I field load cos theta. Okay, here the result that I get from the PSIM, and then below that, this is the calculation that I use, that I calculate on my own. And then for the discussion, you can see this. I already got mostly the calculation and the stimulation, when we compare to, they are same. So we can see we we do this report with less mistake and we can proceed. That's all. Okay, for the last one, I want to tell about the conclusion. Okay, from this project report, the conclusion that I get, which is we can see that all objectives that we already that we are achieve already based on the calculation and the simulation. And all objective that we achieve is we already evaluate the parameter for three-phase system, and then we also can analyze the differences of value from the calculated value and the stimulation value, which is we got it from PSIM software. And then we also justify the normal operating condition for the system. So we all of the objective are achieved. We can see that this project report already complete. So that's all from me. Assalamualaikum warahmatullahi wabarakatuh. Good night. Thank you.